All right, so we're still on the same standard, and we're still looking at properties of exponents. And we are going to continue. We started with multiplication. Today we're going to continue with division, properties of exponents. The other standard, math practice standard number 6, attend to precision. And as we just found out with the area, if I'm asking for the area, you need to write area equals to whatever it is that you get at the end. Yes? Yes. All right. So our objective for today, I can simplify exponential expressions using the division properties of exponents. Let's read together. 1, 2, 3. I can simplify exponential expressions using the division properties of exponents. Now, think about this question. What operation are we focusing on today? Tell your neighbor, please. So, our concept for today is still exponential expressions. So, in your Fourier model, you should have filled this in. We started this yesterday, didn't we? Yeah. Yeah, so you should have filled this in. Some of you did? You didn't? Yeah, I did. Okay. All right, so then let's see if you can do that by yourself. I'll give you guys some time. You got, what is it, 30 seconds? 1 minute. 1 minute. Go. Okay, so let's see. Exponential expressions are numerical and variable expressions raised to a power greater than 1. Were you pretty close? Yes. You wrote your own examples, your own non-examples, and the most important thing to remember is that we're working with expressions only, and we make sure that they have exponents greater than 1. Yes? So, I'm going to move on. This you should know by now. If not, you can fill it out later. But as long as you fill it as much as you can there. We do need steps. Oh, sorry. Underneath the Fourier model, you have space, right? So I want you to write steps. Identify if the exponential expression is a quotient of power or power of quotients. We're learning that today. But notice that the steps sound very familiar, don't they? Yeah. Check this out. Identify the exponential expression is a quotient of power or power of quotients. Notice that we're not doing the product of powers anymore, because now we are in division. That's why it's quotient of powers and power of quotients. Two properties we're covering today. Quotient of powers, power of quotients. Two properties, quotient of powers, power of quotients. Tell your neighbor how many properties and which ones they are. Okay. Second step, use the appropriate property to compute and at the end simplify. Copy that, please. Okay, once again, 3 basic steps. Step 1, identify if the exponential expression is a quotient of powers or power of quotients. Oops, sorry. Quotient of power, power of quotients. Step 2, use the appropriate property to compute. And step 3, simplify. So, bless you. The most important thing to remember is how many properties? 2. Quotient of powers, power of quotients. Yes? Okay, so turn your paper over. In the back at the top, I want you to write quotient of powers property. Quotient of powers property. At the top left, then you're going to write example Q. Okay, copy these. We got 3 to the 6th power over 3 to the 4th power. Underneath that, I want you to write x to the 10th power over x to the 7th power. Bless you. Underneath that, I want you to write x to the 5th power over y to the 4th power. Okay? Pens, pencils down, eyes on the screen, writing utensils down. You'll finish copying right now. I'll give you some time. Okay? Alright, here it goes. Focus on the screen. I'm going to go ahead and use the quotient of powers property. Quotient of powers property. Quotient of powers property. Why quotient? Quotient is a solution to a division. Let's see. I have a fraction here, that means this is a division. That's what's called quotient of powers. Do we have a power here, yes, and we're dividing. So check this out. The quotient of powers property does this. Pay attention. Here it goes. Okay? Talk it over with your neighbor, see what happened with the rule, and why did we get this at the end. So as you're copying it, make sure you're paying attention as to what the rule is. And right now I'm going to ask a couple questions just to clarify our thoughts in regards to the definition. Okay? So here we go. So we said that something's happening here and here, but something didn't happen here. So, to start us off with our definition, asterisk, heart, what operation is this, we said? What operation are we working on right now? Division. So let's start it by saying, when dividing exponential expressions okay, so let's see, who can help us out? What was the rule here? Clear. Okay, but how come we didn't do it here? Okay, so therefore, to clarify, you said we subtract here, but not here. So look at the rule. It says, when dividing exponential expressions of the same base, write it in there, of the same base, comma, what do we do at the end? Subtract the exponents. Period. 10Q. Hands if you understood the rule. Fairly simple, right? Yes. Okay. So now that we have our rule, let me go over this and show you, for those of us that still have doubts and are going to have doubts maybe with some of the homework, what did I say yesterday? When in doubt, factor out. So check this out. Pens down, eyes up there. I'm going to show you how this could be simplified so that you can actually do this without using the quotient of powers property. But let me show you how this works. 3 to the 6 becomes 3 times 3 times 3 times 3 times 3 times 3. Do you agree with that? Look at the denominator. This is 3 times 3 times 3 times 3. Do you agree with that? Yes. Okay. So now, what is 3 divided by 3? 1. What is 3 divided by 3? 1, 1, and 1. Are we there so far? Yeah. So now check this out. Look at the numerator. I'm going to focus on the numerator. I no longer have a 3 here, or here, or here, or here. All these became a 1. Are we there? So check this out. 1 times 1 times 1 times 1 times 3 times 3 becomes 3 to the second. Do you agree with that? Yes. What is 1 times 1 times 1 times 1 on the denominator? 1. And what is 3 to the second over 1? Did I get what I needed to get with the rule? Yes. Can we simplify this one step further? Yes. 3 to the second is 9. Copy that, please. Okay. So, did I just say queso? Okay. So, and let's say you got this answer. Everybody look up x to the third. You use the rule, but you're not sure. What shall we do? When in doubt, fill this in, please, so that you can do this and see if you get this at the end. Go. So let's see. X to the 10 is x times 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 x. This one is x times x times x times x times x times x times x. Do we have giant ones? Yes. Here, 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 and here. 1 times 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 x, x, x. That is x to the third on the numerator. Yes? Denominator, 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. Is x cubed over 1 the same as x cubed? Yes, that's how you can check to see if you got it right. Do you need to do this for the homework? No. If you already know the rule, go straight from here to here. Does everyone understand? Okay, let's do some practice. Copy this next one down, please. Example number 1. Example 1A and 1B. Example 1A says, simplify. A, 2 to the 9th over 2 to the 7th, and B is y over y to the 4th. Copy that and simplify. You got 20 seconds. Go. Okay, let's see. Quotient of powers property says if they have the same base, what happens to the exponents? Subtract. This becomes 2 to the 2nd. Can we simplify this one? This becomes 4. Hands, have you got that? Okay, good. This one, what do we say whenever we have a number of a variable without an exponent? We add a 1. So now we use a quotient of powers property. Y, we subtract the exponents. Let's see, 1 minus 4. This becomes 1 plus negative 4. Therefore, that's a negative 3. Hands, have you got that? Okay, let's crank it up a notch. Copy this one. Example 1C and 1D. 1C is m to the 5th, n to the 4th over parentheses m to the 5th, close parentheses to the 2nd power times n. D is 3 to the 5th times 2 to the 4th times 4 to the 3rd over 3 to the 4th times 2 to the 2nd times 4 to the 6th. We're going to do C together because I want to see how you do. Okay, here we go. So, look at the numerator. Do these have the same base? M and N are not the same bases, so we cannot simplify, right? However, M and M are the same base, but there's a problem here on the denominator. What do you see is the problem? There's a parentheses and a 2 on the outside. So we need to simplify this first before we do our quotient property, yes? So check this out. Let's simplify this one. Let's start in the denominator. What do we do here? Yes? Multiply. So that becomes what? M to the 10. And I bring over the n, and what is the exponent of the n? 1. Okay, so we're done with here, and now we bring these over. M to the 5th, n to the 4th. So, same basis, m and m. What do we get? M to the negative 5, because we subtract, right? 5 minus 10. How about the n? What do we get? N to the 3rd. Hands, have you got that? Okay? Yes. Okay, we subtract these, right? 5 minus 10. This becomes 5 plus negative 10, and that becomes negative 5. That's how we get that. Everybody got it? See if you can simplify this one by yourself. They're already same basis here, here, and here. Write them here. And it's fine right now to leave it in with a negative exponent, and I'll talk about that right now. For right now. Go. Okay, let's see. 3's have the same base, yes? So 5 minus 4 is 1, so this is 3 to the first. So far so good? Times. 2's have the same base, so 4 minus 2 is 2, so this is 2 to the second. So far so good? Times. 4 have the same base, so 3 minus 6, that's 4 to the negative 3. Hands if you got that. Okay? Like I said, for right now it was okay to leave it with a negative. However, from this point forward, I'm going to explain why we cannot have negative exponents. Okay? From this point forward, no negative exponents. Let me show you why. If I have 3 to the second over 3 to the fourth, pay attention to this one. I'm not going to use the quotient of powers property. I'm going to actually factor it out and simplify with factoring. This becomes what? 3 times 3, yes? This becomes 3 times 3 times 3 times 3. Do you agree with that so far? This is a 1, this is a 1. So, what do I have in the numerator? 1 times 1 is 1. Denominator is 1 times 1 times 3 times 3. This is 3 to the second power. Do you agree that this is this? Yeah. So far so good, yes? Yeah. Without using the quotient of powers property. However, we learned the quotient of powers property today, and I'm going to do that right here next to it with blue. What does it say? If it has the same base, we subtract the exponent. So what is 2 minus 4? Negative 2. So we're saying that this is this, right? But we're also saying that this is this. Do you agree with that? So we're saying that this is this and this is this, so that means that this has to equal to this. And I just proved to you why whenever we have negative exponents, we write them like this. Now in the past your teachers told you, you just have to write the reciprocal inverse. Remember that? But now you know why, because if we factor it out, the simplification becomes a fraction. Does everybody see it? For those of you that don't see it, let me show you. Look up to the screen. So what we're saying is this. Whenever you see a number with a negative exponent, this becomes 1 over 3 to the positive exponent. Do you agree with that? So check this out. So let me ask you this question. This has a negative exponent, and I wrote it in the what? Denominator. Do you guys see that? And it became a what? Positive exponent. Are we there? With that same thought, look up please. Look at this one. Which one has the negative exponent? M. So therefore, where should it go? Here it goes again. Look at this one. This was a negative exponent of 2, right? We wrote it in the denominator, it became a what? A positive. This one has a negative exponent. Where should it go? In denominator, and it becomes a positive. This one stays in the numerator because it has a positive exponent. Do you guys see that? Copy that, please. And copy this. Alright, check this out. Now, let's look at this one. Everybody look up, please. Look up. Look at this one. Look up. Which one has the negative exponent? 4. The 4. So where would that one go? In the denominator. It becomes 4 to the third. What stays in the numerator? 3 to the first times 2 to the second. If we were to simplify this, this is 2 times 2 is 4 times 3, that's 12. 4 times 4 times 4, that's 64, and we can simplify this, right? Copy this, please. This becomes that.
Will that be the homework?
Yes. All right, here we go. Tutoring is going to be starting next week from 3:05 to 4:05. I'll be here an hour after school. And what we do, it's not like your other tutorings. Here we actually go through the entire homework and we finish it here by answering questions from the homework. Okay? Let's continue. Copy this down, please. Oh, my bad, not this one. Hold on.
That's too much work.
This one. Copy this. Power of quotients property. Power of quotient's property. Yeah. So we already did quotient of powers. Now let me show you power of quotients. And this one, right, example super duper Q. Open parentheses. 2 to the third power over 3 to the fourth power, close parentheses, all that to the fourth power. Pens down. Check this out. Eyes up here. Yesterday and the day before, we covered stuff like this. Everybody look up. Do you agree? Parentheses with an exponential expression and an exponent. And what do we do with these two? We multiply. However, now we have a denominator. Well, look at this. Pay attention, please. Look up to the screen. Tell your neighbor what to do. So copy that, please. And yes, the rule says that for the power of quotient's property, you multiply the exponent outside times the exponents on the numerator and the exponents on the denominator. Are we there? Okay? So, let's write a rule. Parentheses. I'm sorry, asterisk, heart. Aww. When raising an exponential expression that is a fraction, comma, we multiply the exponents of the numerator times the exponent outside the parenthesis. Are we done? Let's see. When raising an exponential expression that is a fraction, we multiply the exponents on the numerator times the exponent outside the parentheses. We're not done. What are we missing? No. This is the numerator times the exponent outside and the exponents in the denominator times the exponent outside. 10Q. After the comma, and the exponent, parenthesis. Your worksheet is in the back under the clipboard. Make sure you work through those. Hold on to that. Work on those over the weekend. The video will be uploaded if you need to revisit. See you guys till Monday. Enjoy your homework.